Radar plotting is, without question, one of the most critical skills for safe navigation at sea. It isn't just about drawing lines. It's about accurately assessing collision risk and taking early, effective action. In this video, we are going to walk through the complete procedure of manual radar plotting, step by step. We'll cover exactly what you need to know for both onboard operations and your maritime examinations. Section 1, the foundation. Before we draw, we have to calculate. Manual plotting helps us determine 4 vital pieces of information: the target vessel's course, its speed, the closest point of approach, CPA, and the time to that CPA. Step 1, radar setup. First, let's get the equipment ready. Set your radar to relative motion, preferably north up. Select a suitable range scale, usually 6 or 12 nautical miles, and fine-tune your gain and clutter. You need a sharp, clear target echo to work with. Step 2, target selection. Next, choose a steady, well-defined target. Precision is key here. Note the exact time, the bearing, and the range of the target. On your plotting sheet, mark your own ship right at the center. Using your observed bearing and range, plot that first target position. Label it clearly with the time. We call this position O. Now we wait. After a fixed interval, usually 6 minutes for easy calculation, take a second observation of that same target. Plot this new position and mark it as A. Join points O and A and extend that line past the center. This line represents the relative track of the target. By measuring the distance between O and A and applying your time interval, you can now calculate the relative speed. CPA and TCPA. To find the danger zone, draw a perpendicular line from your own ship's position to that relative track. This gives you the CPA. Measure that distance for your DCPA and calculate the time it will take to reach that point, your TCPA. The golden rule of navigation. If the bearing remains nearly constant and the range is decreasing, a risk of collision exists. Every assessment you make here must strictly comply with COLREG Rule 7 and Rule 8. So far, we've assessed the risk, but to take the right action, we need to know what the other ship is actually doing. We need its true course and true speed. The vector triangle. This is where many students get confused, so watch closely. From your first plotted position, point O, draw your own ship's true vector. The direction is your true course, and the length is the distance you traveled during that 6-minute interval. Step 2. Completing the triangle, W to A. Label the start of your vector as W. Now complete the triangle by joining point W to your second plot, point A. This final line, W to A, represents the target vessel's true motion. The direction of the WA line gives you the target's true course, measured from true north. The length of that line, when converted using your scale, tells you the target's true speed. Here is a critical exam tip. Always remember, the own ship vector is drawn from the first target plot, not from the center of the sheet. Get this wrong and your entire calculation fails.